In this video, I'm going to show you how to identify trends from your data. Okay, and I'm going to be focusing on the data from graphs in this video, but you can look at tables to investigate trends. I just prefer using graphs because I just find it super easy to look at the data visually and see what's going on. So when you identify trends in data, you are trying to find what are the main ideas that this data is trying to say. Okay, so for example, you might want to identify the direction that the data moves. Is the data moving up? Is it moving down? Okay. Or you might want to find the highest number, the lowest number, maybe some outliers. That might be interesting. Just what are the main ideas? So here is an example of a graph that we could identify a trend from. Okay, so having a look at this graph. In fact, these graphs are a little bad because they're missing something. They're missing their axis labels. Okay, they would not get full marks if Mr. Yan was marking their graph. Okay, so I believe this is meant to say year. All right, so I'm going to put that in for them. All right, so having a look at this, I'm going to zoom in just so I can see it better. Okay. So here we can see that we've got the number of animals in the park, and on the left, it's starting with the white rhino. And they're tracking the number of these animals as time goes on. Okay, so on the left we've got the white rhino, and on the right we've got the black rhino. Okay, so we're seeing how do these numbers change as time goes on. Well, if we have a look at this left graph, what happens to the direction? Okay, what happens to the direction that the data moves? Well, in this case, the direction is downwards, right? As time goes on, as time is increasing, the number of these white rhinos decreases. In fact, that's what I'm going to write down. Okay, so the first trend I see is as time goes on, the number of white rhinos decreases. But what happens with the black rhino? Okay, well, we can see pretty much from 2014, as time goes on, it's increasing. Okay, so we could say as time goes on, the number of black rhinos increases. Is there anything else that's interesting? Like the lowest number. I mean, we saw here, there's a little dip at 2014. That's possibly interesting. So maybe the black rhinos had a dip in 2014. And after that, they increased. Whereas if we have a look back at these white rhinos, well, after 2015, that's when it really started going downhill. Okay, so maybe, so the number of white rhinos was stable. Okay, the numbers kind of stayed the same from 2013 to 2015. Okay, so the number of white rhinos was stable from 2013 to 2015, and then decreased. So all of a sudden, I've come up with a lot of different main ideas. Okay, and these are examples of how you can look at data, look at this graph, and extract some of the key ideas, right? What is the direction that the data moves? What's the highest number? What's the lowest number? Are there any outliers? Okay, what's an outlier? Well, let's say that I had a data point that was all of a sudden all the way up here, but everything else was really far away from it. Well, that probably tells me that this data point is wrong. I made a mistake somehow, and that's an outlier. And with outliers, we actually remove them and we ignore them, okay, because they don't give us any information about our system that we are testing. It just tells us that we made a mistake, and so maybe we need to retry it. Okay, is there anything else? Well, often a very easy template to follow, okay, often a very easy template to follow is as the independent variable. In fact, we're going to use our formulas. Okay, so this is essentially the formula that you can follow to identify a trend, and this is specific to line graphs, okay, which is when we have quantitative data for the independent variable. Okay, so we've got the independent variable, so we will just insert whatever our independent variable is there. We've got our dependent variable, which we would insert there, and then we would need to make a choice. Okay, so as the independent variable increases, the dependent variable increases or decreases. Okay, and so, which is essentially what I've actually written here, right? As the time increases, the number of white rhinos decreases. As time increases, the number of black rhinos increases. Okay, those are the main trends. And then I've actually taken another step, right? So this is kind of like more extended. Extended, right? These trends that right? These trends are kind of more like extended ones. These ones are the basic ones to identify. Okay, that's all well and good if you have a line graph, but what about if you have column graphs? Okay, so once again, we've got an issue with this graph that Mr. Yu needs to fix up. Okay, so we've got, for this one, number of insects collected. And that should be over here on the left. Okay, so I'm just going to put this over there on the left. What trends can I see? Well, because I don't have a line graph, I can't use my basic formula. Okay, I can't use that because that's not going to tell me anything. So I can't use the direction that the data moves. Right, there is no direction because there are no numbers for the independent variable. Instead, maybe looking at the highest and the lowest numbers, or maybe some outliers, could be interesting. So, having a look at these different traps, all right, I've got trap A, B, and C, and then different kinds of insects that they have collected. What is the best trap for collecting hornets? Well, it's probably going to be trap B because it collected the most of them. Okay, so we could say trap B collected the most hornets? Okay. Which one collected the most wasps? Trap A. Okay, trap A collected the most wasps. And trap C seemed to collect the most honeybees. Now, I can actually improve this a little bit, right? Because I've said which one collected the most. How could I improve it very easily? Well, which one collected the least? So, which one collected the most hornets? Trap B. But which one collected the least? Trap A. Okay, so trap A collected the least. All right. Trap A collected the most wasps, but which one collected the least? Trap C. Okay, so I can just say, and trap C collected the least. And then finally, with the honeybees, trap C collected the most of those, but which one collected the least? It was trap B. So trap B collected the least. So that kind of gives me a good idea as to which trap I should collect. Really, it depends on what insect I'm trying to trap. So this would be essentially, right, this is more of a, oops. This is kind of like a basic basic trends that we've identified, right? The most and the least. But if we have another look at this, what trap looks to be the best overall, right? It's kind of okay at all of them. Which one seems to be okay across the board? Well, it looks to be trap A. So that's kind of an extended one, right? So this is like an extended trend. When I say extended, it's kind of like, using your brain more. It's a really good one. It's a really good trend to identify, right? We could say that trap A collects the most consistent number of insects across the board. Okay? So that, we're basically saying here that trap A it collects not the most of anything apart from the wasps, but it collects a really good number of each of them. Okay, so maybe if we only had money to buy one trap, which one should we buy? Probably trap A in that case, right? If we had a big problem with all of these insects. Okay, so that is a really high level trend to identify. So, how do we identify trends? We just think about the direction that the data moves, if we're talking about a line graph, as well as the highest number that's involved, the lowest number that's involved, and are there any outliers, data points that shouldn't be there because we made a mistake.